Assalamualaikum warahmatullahi wabarakatuh. My name is Mubarak. I'm from project-based learning Swarm Drone night class semester 5. Now I want to introduce you to our project-based learning is Swarm Drone. So our division arrangement, our project manager is Mr. Satria Wijaya, and following by division communication by Rio Erpanta Ginting, Sarah Anggraini, and Rofio Thoriq Alfalah. Next, following by division visual by Jansensius Thomas Indrawan and Rio Fernando. And then we have division motion by Zul Priyadi and myself, Muhammad Thoriq Mubarak. And the last one is Suryadi Saputra. So, what is swarm drone? Drone is technology that we know that we use it all the time, like for videography and everything. So what is swarm actually? Swarm is stand for smart far wide, smart or fight team array or configuration model. So it basically made for military, but it can use for other more. So, and what is our project overview? We have three objectives of our project. The first is drone swarm formation. The second is autonomous navigation and communication protocols. So what is drone swarm formation? As we know, swarm stands for drones that have like many other than one. So we use formation to do something. Second, we have autonomous navigation. So we have this division visual. We use it for human tracking, like face tracking or object tracking. So we use deep learning object to follow the navigation. The third is communication protocols. We use multiply drones, so the other drones can communicate each other. Next, why is drones? The first, we have the flexibility, the size, the minimalist, so we can carry around, so it's flexible. The second, it has access to the limited access, so we don't have to do it by our own. We just use this drone and then fly to the limited access. The third is efficiency. It's called efficient because it's easy to use. We just use drones and we don't have to do anything. The fourth is cost effective. Other than other vehicle like mobile or like land and helicopter, jet, we use drone to search around. It costs less than we have to build like helicopter, so it costs efficient. The fifth is remote control. It's easy to use. We just have to use remote control. The sixth is monitoring and mapping. Like the previous I said, many people these days using drone as a photography and videography. It also can use to mapping an environment. So we just use the drone, the camera, and do all the mapping. The seventh is aerial photography and videography. Like I said before, it used for videography and photography. The eighth is precision agriculture. The ninth is search and rescue. We also use it to search human or maybe search something in the limited access area like the forest, the mountain. So we don't have to risk our life to do it. We just send the drones and we just play from far. The 10 is scientific research. The drone can use this to do a scientific research, like I said before. We use it to go to the limited access to explore new areas, so we can use for scientific research. The 11 is recreation, and the 12 is reduce risk. What mean of reduce risk? So we don't, like I said before again, we don't have to use human to do search a new environment, to do dangerous thing, we just have to use drones. We can use multiply of them to search an area and like that. Next, this is our mechanical design of our drone. Next is the basic concept of drone. So we use weight in the bottom of it, and we use 4 propeller to lift it up, and the weight is just for the stabilizing, so it can move stable. In this drone, we only use 4 main components of this swarm drone. The first, we have the ESP32 for the microcontrol of this drone, and then we have 4 brushless motor, and we have 4 ESG for control the brushless, and then the last, of course, we use the battery to maintaining the power. This is the electrical design of our electrical of the drone. This is the flowchart program for the drones. This is the mechanical design of the gimbal. The basic size is the length of around 100 centimeters, the width from 100 centimeters, and the height is 100 centimeters. And then we have the electrical design for the gimbal. Of course, we use electrical for gimbal to measure the rotation and for measuring the stabilization. This is the flowchart program that we use for the gimbal. So what our progress in this semester of our swarm drone? The first, we finally made a GUI for drone controls. The second, we finished all the electrical for the drones, and we assemble all the parts of the gimbals except for the sensors, but the physics is done. And for the design, we updated design for a lighter model and added feet to the drones. And also we have finished 1 more drones frames. So we attached the brushless and all the frames that made from plastic. Next, this is a few results of our testing our drones. You can see.
Ini udah kencang ya? Oh yang udah ya? Maling-maling aja ya? Cuma ada yang hati itu. Dulu kan 2020 kan kita mau berapa pegang kan? Ini ya. Dulu udah dikasih 1.500.
So this is the sum of our obstacle in this semester. We have 3 main problems. The first is the library compatibility issue. So we use Arduino as a program control for the microcontroller. Sometimes we have this library issue like uncompatibility of the hardware and the software. We have that problems like a few times. And the second, we lack of reference. That means this project swarm drone has just a few of reference, so we didn't have much reference. So we barely just use like ChatGPT and a few drones module from internet. It's just very less than other project. This is very new in this university. We also the very first time who actually do this project. The third is uncompatible hardware and errors. So we face a problematic hardware issue such as like a lost USB cable. Sometimes like the SP32 doesn't work at all. So that's like the main reason why we take so long to configure these programs, because when we use the ESP32 we thought we done it, but when we try it, it doesn't work. The first we thought it's the program, but after all it's just the hardware issue. So it might be our obstacle of this semester. This is our project plan for this swarm run. We already did some of the progress. We just stay in this control speed motor. We already made the GUI for the controller, but the controller still doesn't work at all. So we still stuck in that situation. So we may be gonna improve in the future. So this is all we got. After control speed motor, we're gonna monitoring the real-time speed motor and test flight, calibration. There's still a lot of steps that we need to configure. This is the table of our overall progress for a semester. The gimbal is around 3.2% of progress. I mean the gimbal program, and then we have the drone program only set for 8.3%. The build gimbal is we did a lot in this semester. We built around 50.52.2%, and the rest is for the build the drone. This is our overall progress for this semester. This gimbal program we only done it for 10%, the drone program in only 12%, and then the drone is around 25% because we need to build like 4 drones, so we only finished once, and the second is not finished, the electrical. And then for the gimbal is still 40% from finish. That's all for my presentation. If anybody have any question, you can ask in the comments. Thank you for watching me. See you and good night. Okay, that's it for our PBL presentation. Now moving on to a few questions that we have. The first is, what is the importance of autonomous robot nowadays? Okay, the importance of autonomous robot nowadays is very significant. Why? Autonomous robot is basically created to assist human, or maybe in some cases replace them at manual labors of human. They are very efficient and time saving. The autonomous is very accurate in the process of working, so it may be gonna replace human workers. In this topics, it's undeniable that maybe some human gonna lose their jobs because of this, but as a human we must be able to adapt in this technological era. So we must learn more new skills and try to adapt to this era. So that's it for the autonomous robot. Okay, now continue to the instructive presentation. For now I'm gonna explain how to use a 3D printer. To use the 3D printer, first we're gonna set up the cable, we attach it to the back, and then we attach it to the power source. After that we turn on the button. After that we use the filament and fill it into place. After we use the filament, now we go to our desktop or our laptop. We're gonna use some software. I currently use Ultimatura. Now do the calibrating. We have to make sure that the nozzle is working correctly. After we done calibrating, Now we move on to the 3D design that we want to print. We insert the print. If the 3D design is very unstable, we can use some support to maintaining the weight of the design. And then we just have to wait until the 3D printing process is done. After done, we have to make sure that the area of the printer is clean, so we must make sure it twice, so we have to make sure it cleans. After that, we can turn off the machine and then leave it on. Okay, for the last presentation, should we add mental health for this curriculum in Polibatam? In my opinion, mental health is very important at some point, but for the curriculum, I think it does not fit for that. In some prodi, maybe like psychology, maybe they should add it, but for others like our robotics or mechanic engineer, I think we shouldn't, because it's some point is not part of this case. Mental health is very important, but to learn it, we just have to have a faith and learn about God. It's barely about religion. If we have faith, we never gonna miss our mental health. So for mental health, I think it's very important, but for to be added to the curriculum, I think it does not fit. For others prodi like us, for psychology, they have to, because it's their study. So that's it for me. Thank you for watching. If you have any comments, you can comment. If you have any question, you can question in the comments. Okay, thank you for watching and see you next time.